All right, we've talked about the origin of the universe. We've talked about the origin of our solar system. We've talked about the origin of our planets. And now we're going to focus in on Earth, which is going to be the focus pretty much from here on out, right? Talking about Earth's formation. All right, so we talked about in the nebular theory how planetesimals grow by continuous collisions. And over time, those smaller planetesimals get bigger and bigger and bigger and bigger and bigger until eventually we get our planets. And the early planets, the protoplanets, they were irregularly shaped. They were bumpy, right? They were made just as a mass of stuff that had clumped together. And the proto-Earth, right? Eventually, as it gets bigger and bigger and bigger, it begins to heat up and become kind of soft. And the heat comes from a few different places. The heat can come from heat produced during collisions, right? When you rub your hands together, your hands get hot because of the friction that produces heat. Same thing happens when material collides into different material in our solar system, right? It produces heat. Heat is also produced when matter is squeezed into a smaller and smaller and smaller volume, which is happening because of gravity. And finally, heat is produced through radioactive decay. And this is an important one that especially if you stay on in geology, you're going to hear a lot more of. Radioactive decay, that's just the spontaneous breakdown of an atomic nucleus, right? So we talked about how atoms are made up of a nucleus in the center with electrons orbiting outside of that nucleus. Well, if that nucleus decays, right, one of those particles within the nucleus is released, and that happens spontaneously, right? That release of energy produces heat, and we call that radioactive decay. So there's those three sources of heat, radioactive decay. Today, we don't have as many collisions, right? We don't have an asteroid hitting Earth all the time. Earth is no longer squeezing into a smaller and smaller volume, right? It's pretty much packed as small as it's going to get. So today, most of the heat within Earth comes from radioactive decay. And within Earth, it is freaking hot. It's very, very hot within Earth, right? So as gravity is reshaping the proto-Earth into a sphere, remember it's very hot, it's very soft, it's molten, right? If you were to visit Earth at this time, it would just be a molten blob of magma, right? There would be no solid rock for you to stand on. And when the Earth is molten, the nickel and the iron melt and they sink down into the interior of Earth. And these materials sink down into the middle of Earth because they're dense metals, right? They're dense, they're heavy, so they sink down into the depths of Earth. So they're pulled in by the gravity. So as iron and nickel, these heavy elements, sink down into the center of Earth, that leaves the lighter elements closer to the surface of Earth. Right? And this is called differentiation. The Earth differentiates into a core that has the really dense iron and nickel metals, and a mantle, which is close to the surface and has less dense material, right? Not as much iron or nickel. All right, so the Earth is forming. It has differentiated into a core and a mantle, the metallic inner core, the mantle, not as metallic. And soon after Earth forms, a protoplanet collides with it. And when that protoplanet collides with it, debris from the surface of the Earth are blasted away from the Earth, scattered out into the Earth. And that material, because of Earth's gravity, even though it's blasted away from the Earth, begins orbiting Earth again. Just like our satellites, right? And just like our rocket ships, when they blast away from Earth, they can continue to orbit Earth because of Earth's gravity. And so after that protoplanet struck Earth, a lot of material from Earth was blasted out into space. It started to orbit around Earth. And as it orbited, it clumped into itself. And eventually that material clumped together to form, you guessed it, the moon. Right? So the moon is actually made from material that was once part of Earth. Right? It was just blasted away to form the moon. All right, I know I've talked about a lot. We have talked about so much, the beginning of the universe, the beginning of our solar system, the beginning of Earth. everything that we have talked about so far happened during what we call the Hadean Eon. The Hadean Eon, it's not even on this geologic timescale because it's so long ago. It predates the oldest eon that's included on this geologic timescale called the Archean. And Hadean Earth would be unrecognizable to us today, right? It was hot. Much of Earth was molten. There wasn't much solid rock. It was constantly being bombarded by meteorites. There was little to no atmosphere. There were no oceans. Cosmic radiation was high. It was just be a miserable place to be, right? And all of that happened before what you see in this geologic timescale, before what we're going to talk about for the rest of this class. Eventually, as we know today, right, eventually the atmosphere developed from volcanic gas. The Earth cooled down enough that moisture condensed and rained down to create an ocean. Some of these gases and liquids could have also been added by passing comets, right? Eventually, Earth cooled down and the spheres that we know today were created. But we also know that when Earth was first created 4.6 billion years ago, it looked very, very different from today.